Swayam Prabha. Digital India. Educated India.
Right, makes sense. Because of this exponential term here, you have this, but in fact it will go exponentially afterwards. I have put linearly because I every day see my system how it behaves, because there are other losses in the system, so it goes linearly. But essentially you can appreciate this concept why current increases after certain potential. Am I right? Next question. Some frequency factor. You know A into e power minus A by RT, pre-exponential factor, right? That is a pre-exponential factor. Thermodynamics you have not done, is it? Thermodynamics is not done? Huh? Then you should remember, right? You never heard? Okay. Arrhenius equation, basically there is a rate constant K. How do you quantify the rate constant K? Rate constant K can be bigger or smaller. Because this you are familiar? Are you familiar with this rate expression? So this rate constant, what is the value of this? Value of this depends on what is the value of EA. EA is the activation energy. You might have seen this. This is a reactant, this is a product, and it goes like this. So this is my energy axis, this is my reaction coordinate. And you see reactant is sitting at higher energy than product. So in principle reactant should become product easily, but it doesn't become. Why? Because it cannot go directly like this. It has to go through an activation energy. Any process involves an activation energy. What is that activation energy? The minimum energy that you have to spend to convert R to P. Okay. How you do in a normal chemical reaction? You will increase the temperature so that you are taking R to that activation state. Then it becomes P. Okay, in electrochemical setup, what we do, we will apply over potential and take R to that activation energy and then it will drop. Correct? And you know, in thermodynamics, any form of energy can be converted to any other form. But heat energy cannot be completely converted into any other energy. You cannot completely convert heat energy to any other energy. Still some heat energy will be left. Energy conservation is there. Total energy is constant in the entire universe, no doubt. But once you convert something to heat, getting back heat to that same thing is difficult. That's what your thermodynamics says. Okay. So the same thing will be applied in electrochemistry. In electrochemistry, we will take this guy to here by applying potential. That means electrical energy. But when it comes down, it will not give electrical energy. It will only give this much of electrical energy, this much of heat energy or light energy, depending upon how good is the voltage. So you have taken this fellow to up by an electrical energy process, energizing electrically. But when it comes down, it's supposed to release energy because it's coming from higher energy to lower energy. But it gives two forms of energy now. Some heat energy, some electrical energy. So the usable form of energy you get is still small. So that means that this height is there, no? Suppose if instead of drawing like this, let me draw like this. Okay. Now you see, in this case, you have to apply this much of electrical energy and you get this much of heat energy and this much of electrical energy, correct? Now you are applying this much of energy and when it comes back, it is coming back as a heat energy. So it's of no use for us. So this much electrical energy you applied, you have to subtract it from this available energy. So this height you take and subtract it here. That comes somewhere here, right? This height here is same as this height here. Okay. Then what is the usable energy you got? This much only. So now you see, this is called over potential in electrochemistry. Over potential means the energy penalty. But here energy penalty is too much because this energy is much bigger than this. Even though this, according to thermodynamics, it's a galvanic process, it will still need energy. Because activation energy barrier is very high. So you spend a lot of energy, then you don't get any useful electrical energy out. But you will get heat energy out, but not useful electrical energy out. Right, no? So it depends on the what you call potential energy landscape of that particular reaction. Okay. So this is what you will see. So that means if you have a battery based on in a thermodynamics, what you will do, you will go to the table, you will take one redox couple, you take another redox couple, you try to form a battery. So you will take the difference of this potential and that you call it as a E cell. But you will not see that E cell. Why you don't see that E cell? Because there is an activation energy involved in the process. When the battery runs, that activation energy is subtracted from the available energy. Then you get only this much. So when the battery at open circuit condition, it may be 1.2 volt, but when it operates, it may be 0.8 volt. Where that 0.4 volt gone? It is gone for activating the reactant to the activated state. When it comes back, it's supposed to give electric energy, but it's not giving. It is giving heat energy, then rest only electrical energy. Therefore, there is a penalty in terms of electrical energy that we call it as a overpotential. Maybe which is not there in your textbooks, I don't want to discuss, but just wanted to give a brief. Okay. Next question. Is the time over? 5:30. Yeah. Yeah. 1, 2. Why is it getting? This is how it is. Nature things are happening like that only. Why is it getting converted? That's very difficult to answer. Because whatever the thermodynamics says, it's the same thing. You convert one form of energy into heat, but heat cannot be converted into that form completely. Okay, it will form. So I need not say that exactly that much heat will come, maybe even lesser than that, but you cannot convert heat back to that. That is a basic thermodynamics principle. It is how the molecules are made, it is how the reaction happens. Why it is happening? It happens like that. And that is why we have all these inefficiencies. If you don't connect resistor, reaction will happen in a rush. Correct, no? If you want to slow down the reaction, what will you do? If water is going through the pipe, how will you slow down? You close the tap, you narrow down the hole, then less water will come out. Same here. Instead of water, imagine this electron. Instead of hole, imagine there is a resistor. The resistor will play the job of the increasing or decreasing the diameter of the hole. So the resistor basically controls the rate of the reaction. In a regular chemical reaction, you take A and mix it with B and form a C. It can be mixed, it will form at its own rate, right? At its own rate, it will form. If it's an explosive reaction, as soon as you mix, it will blast, correct? But even an explosive reaction, I can make it slow by putting a resistor, so that I control, because the resistors allows only certain amount of charge per unit time, correct? No? Therefore, I control the rate. In other words, by putting the resistor, the time required to reach the equilibrium, I can delay, correct? Why? I want to do the reaction in controlled manner. Because suppose some process requires certain amount of energy, you don't oversupply the energy. You understand, no? Suppose you want to erase something here, take a blade and you are doing slightly like that. But instead of doing that very fast, you do with the blade, what will happen? It will, instead of removing, it will start scratching. So it will do more damage rather than what we need. Same here, you let the electron flow very fast, there will be a lot of heat energy will be generated. You see, when this goes to activation state, comes down, there is a lot of heat energy generated. All heat will generate in short time. Then what can happen? Depending upon how big the battery is in terms of the charge it stores, then the amount of energy that is liberated can be huge. If it is a huge, what will happen? Battery will suddenly heat it up. If battery heats up, what will happen? Other associated process will start. If it is a liquid based battery, because of the heat, the liquid will vaporize. Or if you have a low melting electrode, then the electrode will melt. Or if you have a plastic in your battery which can catch fire, it will catch fire. So all that will be triggered parallelly, right? Therefore, we have to control the rate at which we do. For example, lithium ion battery in your car. Why can't we charge fast? I can do. But that charge, instead of doing the reaction I want, it will do something else. It will heat up the battery. That heat will melt something. Then battery will lose its shape. Then thermal runaway situation will arise. Battery will catch fire. So there is a rate at which only I can do. I can't open. It's like opening a floodgate. Immediately you open, everybody downstream will die. You control the way you do, you can use it. You can enjoy your river flowing near your house. If real bulges near your house, you will not enjoy. Correct? No. Same here. Here we want to do a work in a controlled manner. Therefore, we put a resistor. That is a big question. You can, at your level, you can say if you change the catalyst, a better catalyst, it can lower the activation energy. At the electrochemistry level, I would say there is something called over potential we can use. So that means I can increase or decrease the potential of the electrode where the reactant is in contact. If I do that, what will happen is, imagine instead of reactant being here, if I put reactant here. How I do that? I apply a potential to this electrode. What is the potential? Adding or removing electron. By doing that, I can take the reactant up or down. Why? Because the reactant is already made a bond with your electrode, right? So it is a part of the electrode now. So I can, any electron I add to the electrode or remove will affect the R reactant. So I can make that flow go up or down, like a CCM case. CCM, I connect on a terminal, I can make CCM give out electron early or late. Same here, I can raise or lower. But if I raise it, my activation energy drops actually, because it is gone up. But you remember, you have used this much of energy to raise this fellow. That energy is called over potential. That will be subtracted from the available energy. Remaining only you get. Okay? You understood? For adsorption. Non-metal. Non-metal, we have some other problems because they are not conductors, Then for the electron to flow into the electrode itself, we have a lot of problem. That and all will come in the penalty. So we don't use. We need a conducting matrix. Yes, that's what your electrochemical table says. Depending upon the redox couple you choose, potentials are different.
So based on the redox reactions, again the reaction. That's what the equilibrium.
Yes, same mechanism. Here we both said same equilibrium. There what will happen? If I take sodium and chlorine, then sodium plus will be in equilibrium. The other side, chlorine, chloride will be in equilibrium.
Sir, and also could you explain how the salt which ensures that the reaction keeps on going on?
Salt bridge ensures because, so now we have an electrode here and this is a salt bridge, this thing, okay. So suppose let us take zinc and copper. Now if it is in a galvanic mode, normal conditions, zinc will be your anode, copper will be your cathode. So I am going to connect this fellow. Then zinc will go into the solution. Electron will come here. It will go like that. It will come here. Then copper 2+ will become copper and deposit. So then what happens? The concentration of copper here will decrease. Concentration of zinc here will increase. But it doesn't have a counter ion. How only positive ion can survive? It needs a counter ion. How only negative ion can survive? Copper sulfate. Copper has gone. Sulfate will be left. So you will have a positive charge here, negative charge here. That's again double layer. Whenever you have a double layer, then a potential will develop.
Yeah.
And that potential will oppose this electron flow. To nullify that, what we do? We have potassium chloride here. What it will do? Here it needs an anion. This anion will be this anion. Here it needs a cation. That will be this cation. But why potassium chloride? I don't know, potassium chloride or potassium nitrate, something is used. Why that is? Because we choose a salt in the salt bridge such that their transport numbers are equal. That means 0.5, 0.5. The total current, 50% of the current carried by K plus, 50% of the current carried by Cl minus. You see, I have transported 50 K plus this side, Cl minus this side. That means 50% of current going this way, 50% of the current going this way, which I could establish. Okay, if these two ions doesn't move at same speed, what will happen? Here also there will be a double layer formation, which we call it as a liquid junction potential. You have a liquid, imagine it like this. We have a liquid here and we are bringing in contact with another liquid, both are say KCl. Say this is 1 molar, this is say 0.5 molar. There is a concentration gradient. Things will start mixing now. But Does the K plus and Cl are together in the solution? No, they are ionized already. Now imagine K plus moves faster. Then what will happen? K plus will go faster this side. Chloride ion will be trailing that. When 4 K plus goes, maybe 1 Cl goes. Then this side of the solution will be more in anion. This side of the solution will be more in cation. So positive charge, negative charge. Then in this imaginary boundary, you will have a potential developed whenever there is a charge separation. That potential is called liquid junction potential because it's at the junction of two liquid. The same thing will happen within the salt bridge. Okay, let it happen. What is the problem? You are interested to find out E cell. E cell is E cathode minus E anode. But you will be start calculating also the liquid junction potential. Why? The voltmeter that you connect here, the voltmeter that you connect here will measure wherever potential drop in this circuit, everything it will sum it up. Correct, no? That if you have a salt here, whose cation and anions moves at different speed, then you will produce instantaneous liquid junction potential. Then what the voltmeter reads is potential difference between these two plus this liquid junction potential. That is not the true potential you want. You want a potential difference of between the two electrodes only. Right? So if you want to do accurate measurement, you should ensure there is no error. That is why in the salt bridge we are using a salt whose transport number are equal. That means ability to carry current is equal. We have seen what K plus moves this way, that fellow moves that way. So they are going in opposite direction, but they are carrying current. What current is? Ionic current. Platinum black with the hydrogen, if you are taking only one electrode, there is no salt bridge. If you are taking two electrodes, you need a salt bridge for the operation of the cell.
That's what does the salt bridge do there? That alone I'm confused.
It is one side if you are producing proton, where is the negative ion? The salt bridge will give the negative ion. The other side you are consuming proton, then negative ion is left, what it will do? It needs a positive ion. That is why. But in reality, we will not use salt bridge when you are making a device. When you are making a device, we can bring both the solution in direct contact. Imagine your liquid junction potential generated is only few millivolt and I don't care about it. I want only my system to generate some energy and I have to do some electrical work. But there is a small liquid junction developed which I am ready to sacrifice. That means if the potential of the cell is 1 volt, I have 3 millivolt of liquid junction developed. 1 volt minus 3 millivolt is 0.997 volt. Correct? That is okay for me. Then you can operate. But for the measurement's sake, when you do some measurement, it has to be accurate. Device has never been accurate. Devices, when you do, there are a lot of inefficiencies here, there, in the sense, there are a lot of energy wasted in a device. When you make a pump, you cannot say every electrical energy that you pump in is converted into mechanical energy. It will not. Pump will waste some energy as heat. Only you subtract the heat from the total energy, remaining energy only converted into mechanical energy. Correct, no? Same problem here. Because any real device you take, it will not work at 100% efficiency. You give 1 unit of electricity, maybe 90% of that only used for your work, 10% gone as heat. It's like over potential here. The difference, the heat, amount of heat you generate is over potential. It's not energy difference. When you have sodium and chloride, the difference, then the probability of this falling will increase.
Okay, sir.
Close, the probability of falling will decrease. Right, no?
Sir,
So
I
it's
thought.
not energy, it's the energy difference between the two electrodes.
Yes, sir. You mentioned the only at a particular energy when the A molecules collide, the reactants will be formed. So
That's the threshold energy. After that, it will be continuously happen. That's the minimum energy you need. After that, reaction will be continuous.
alright.
You see now current going up. That means more of A goes to B in each potential after that. Correct? Galvanic cell gives electrical energy.
Like, will it be as efficient as the electric cell? Like, we use
What
like
is electric
batteries.
cell? That is same battery. What we are discussing so far is only
Like the
battery.
electrolytic cell, so it's better than the galvanic cell.
Electrolytic cell cannot power your circuit. You have to energy you have to give to the electrolytic cell. Your cell phone, for example, when you put it for charging, it is electrolytic cell. When you are using cell phone, it is same cell is a galvanic cell. You should know. Yeah. Mike.
So there's some batteries that are rechargeable and some that are non-rechargeable. What makes the non-rechargeable ones like that?
Imagine you have water here. You want to put the water in the overhead tank. Imagine the overhead tank is in the other side of the mountain. What will you do? Give up. Because you have to spend much more energy than what is required to do that. In other words, in the process of taking this water up there, there will be so many leak here, there. By the time you go up there, water may not be there. Put it in chemical terms, when you are trying to do a reaction, instead of an intended reaction, some other reaction happens during charging. Then you cannot do. For example, proton going to hydrogen. And you wanted to do sodium ion going to sodium. So you are taking a sodium chloride solution in water. In water you have proton also, you have sodium ion also. Now your intention is converting sodium ion to sodium. You pump the electron. But before sodium ion becomes sodium, proton will become hydrogen. That means water will go away, you will have a dried salt will be precipitating. So now this reaction by nature is devised such that we can't achieve sodium ion reduction in water. Why? We can't. Before that hydrogen will vaporize. It will disappear, it will get reduced and become hydrogen. We cannot do. Then in that case, I can only make a primary battery, wherein reaction one way is we will do and make electrical energy. The reverse, if we try to do, some other reaction is happening, battery is dying. We cannot do. So answer to your question is, it is possible, provided you make sure that the electron doesn't go to proton, it goes to sodium. How will you do that? You remove water, put a non-aqueous medium. That is what your battery, all your lithium battery has a non-aqueous medium. Therefore, you can, that non-aqueous solution may not get reduced in the potential that you are taking. So, you give the electron, it will go to lithium only. Lithium ion will become lithium metal. So, it is all about the devising a cell engineering. Yeah. What is the electrode will do? Yeah, that will take another half an hour. But I can do it instead of lithium ion battery, I can do lithium oxygen battery if you want, it's easier to do, right? So if I take lithium metal in one side and I have oxygen in one side, so you know the potential of oxygen is more positive and lithium is negative with respect to hydrogen electrode. That means the one with more negative is more electropositive. So that means lithium will oxidize, oxygen will reduce. So lithium will become lithium plus, simultaneously oxygen will go to oxide ion. Then the product is lithium oxide. You got the electrical energy. This is how lithium ion battery work. But in actual lithium ion battery, we will not do this. We will have an electrode called LiCoO2, lithium cobalt oxide. The other side, we will have an electrode called, we never use lithium metal, but for sake of discussion, I will use lithium metal. Okay. Now, what is lithium cobalt oxide? Have you studied solid state chemistry? That is also in the +2. Whatever I need, everything is in +2. How will I answer? Right? What, anybody know what is sodium chloride structure? Crystal structure, sodium chloride. Lattice structure of sodium chloride. Face centered lattice of chloride ion. Yes. Cubic close packing. What is cubic close packing? You take a cube. You take a cube. In the cube, I am going to put atoms in the corner, the face center. Okay. This is what? Face centered cubic lattice. Close cubic close packed lattice, CCP or FCC. You imagine all the circles I have put there is chloride. And I have to now sodium chloride, you know, one sodium involved with one chloride. Right? Now where the sodium will be there? Sodium will be here in the edge center. And in the center. Okay. edge center in the center. Now, if I take this unit cell, this is called a unit cell. And if I count number of chloride ions and number of sodium ions, they should come equal. Is it equal? Is it equal right now? It is not equal. What is wrong in that? It is unit cell is sharing its face with the adjacent unit cell. You understand? That means the atoms in the face center is only contributing half to that unit cell. How many face centers are there? So I got 3 chloride ions from the face. So atoms in the corner is shared by 8 fellows, 4 in the down, 4 in the top deck, right? So how many are there? 8 into 1/8. So totally I have 4 chloride. Then I have to now count 4 sodium in this structure. Let us look at it. I have put it in the edge center. Edge center is common for how many fellows? 4. How many edge centers are there? 12. 12 into 1/4 is 3. 1 in the body center. 4. 4. Totally 4 sodium accounted. So sodium chloride. Now careful. I am going to introduce the structure of lithium cobalt oxide. Imagine you write it sodium chloride like this. When I write sodium chloride like this, no problem. Still it is a sodium chloride. Just I only doubled the content. Correct? Why did I double the contents? I am going to replace all this chloride with oxide. And one of the sodium with lithium, another sodium with cobalt. Then you see LiCO2. So what it means? It means all these circles are oxide. All these squares will be either lithium or cobalt. Imagine the lithium and cobalt arranges layer after layer, right? Lithium layer, cobalt layer, lithium layer, cobalt layer. In the 1-1-1 direction. What is 1-1-1 direction? Miller indices. I don't like these CBSE fellows or any other this education department. Every useful thing they will cut it in your syllabus. If they ask, they will say students are under depression. Then what will you learn? Which one? Okay. 1-1-1 direction means earlier it used to be there when you were a student. Okay. You take a cube. You go 1 unit along the z direction, 1 unit along the x direction, 1 unit along the y direction. You connect this fellow. What you get? You get a plane. That plane is in 1-1-1 direction. Because 1 unit along this, 1 unit along this, 1 unit along this. And if you see actually in that structure, wherever 1-1-1 plane is there, there you will see a layer of lithium, a layer of oxide, layer of sodium, layer of oxide, layer of lithium. So lithium oxide, sodium, lithium oxide, cobalt oxide, lithium oxide, cobalt oxide, lithium oxide. Go on like that. You can see clearly. Imagine this is a tiny cube. So I can take this as 1 unit. Okay. This as 1 unit, this as 1 unit. If I make a tiny cube. Now connect these fellows. It will form a plane. Is this not a 1-1-1 plane? Yes, it's a family of 1-1-1 plane. Now actually if you extend this, the next 1-1 plane will come right here. Okay, next comes here, oxide ion. Next comes here through this thing. So it will go like that. So here you have the third one. This one you have to connect. You will get a triangle. Okay. So you see this. If this is lithium, say this is lithium, in between you have cobalt. And in between the cations, you have oxide ions. Okay. So you have in the 1-1-1 direction, you see a layer of lithium, oxide, cobalt, oxide, lithium, like that. This is a structure of lithium cobalt oxide. It is nothing but the sodium chloride structure. Except that you have a ordered lithium and cobalt layers. And imagine also the defects is coming in the next semester, next year, right? Defects in the solids. Okay. Now imagine I have lithium here, correct? In the vacancy. Now if I remove some lithium from that vacancy, from these spots, from this spot. Imagine these are the lithium spot. This is lithium spot, this is lithium spot, this is cobalt spot. So from the lithium spot, I remove some lithium. If I remove one lithium, lithium exists as not lithium metal there. It's a compound. It's a lithium ion. So I pull out one lithium ion. Then structure, then the matrix will become negatively charged now because I took up cation out. So it cannot exist as negative charge forever. So it has to eject a negative charge. Where from it will eject a negative charge? One possibility is oxide can eject an electron, become peroxide or something like that, or can also become superoxide. Other option is cobalt is a transient metal, right? It can have multiple valency. Imagine cobalt 3 plus now ejecting one electron. It can become cobalt 4 plus. So now lithium cobalt oxide can become lithium 1 minus X cobalt 1 minus X oxide. X is less than 1. X is less than 1. That means if I remove X lithium out of this, okay, I will get X electron out of this. Where that electron will come? From the cobalt. So I distinguished cobalt. 1 minus X cobalt will remain in 3 plus state. Remaining X cobalt will go to 4 plus state. Makes sense? So charge balanced, mass balanced. Now this lithium will through the electrolyte come to this side. There lithium electron will come from the external circuit and lithium ion will come through this solution and lithium ion will come here, take this electron, become lithium metal. This is called charging of the battery. The reverse will be discharge of the battery. You understand? So when I do the charging, I create a vacancy in my lattice. Metal vacancy I create there. Okay. So now let's come back to this. Lithium metal we don't use, is very dangerous. It forms a dendrite, it reacts with the solution violently. What we use lithiated graphite. Lithiated graphite in terms of reducing property is very similar to lithium. What it does, we have graphite is a layered structure. In between the layer we put the lithium. So it will be lithium ion here. The electron will be floating in the graphene layers. Okay. The electron of the lithium will be floating in the graphene layers and lithium will go in between the graphene layers. This is called lithiated graphite. Lithiated graphite is almost in terms of reducing power like lithium. So like a lithium metal. So instead of lithium metal, we use lithiated graphite. That means when you pull out lithium from here, this guy will enter into this lattice. So back and forth you do. That's all. Graphite is such a nice layered structure, it can host lithium inside. That's why Nobel Prize is given to Akiro. He is the one who invented that. Other Nobel Prize is given to Professor Goodenough. He invented lithium cobalt oxide. It was shared by 3 people. The third person is Whittingham. Whittingham shown this process of removing lithium, putting lithium in without disturbing the crystal structure of the compound. I remove lithium from here. That time nothing moves in the structure. It's intact. To practical purpose. There will be some 10% volume exchange will be there. But practical purpose it remains intact. That means it's like you go into your house, come out of your house. Nothing happens to your house. You are a part of the house, right? You go inside the house, you see a house is shrinking. You come out of the house, the house becomes happy. No. Same here. We create a lattice in which lithium can freely move in and come out. That is lithium cobalt oxide. And in that lattice, you pull the electron out, pull the lithium out, along with the electron out, put it in this. So this process of inserting lithium into a crystal structure without disturbing the crystal structure is called intercalation. That intercalation first discovered on titanium sulfide electrode by Whittingham. And that was extended to lithium cobalt oxide by Goodenough. And the same intercalation extended to carbon for the other electrode by Akiro. So these 3 are the seminal innovations which made the battery a realistic one. Which is now driving up to the car, everything is going by that. That is why these 3 guys were selected. Our being itself is harmful environment. What to do? Always see how you become rich. Not like Rajinikanth over a song. You be poor. Then you make your son get graduated. He will improve your life going to some IT job, GT job. and that fellow will accumulate lot of wealth. Then his son will say, I am not going to work like you, as if working is sin. It is not. But sometimes people project like that. I am going to become an entrepreneur. Because he has money background, so he will try to do all these things. Now, at the same time, there will be another family which is poor, which is like your family one generation ago. They cannot aspire what you are doing. You can. Nothing wrong in aspiring. But the chances of you failing is more. Because you don't have money with bandwidth. Then you may have a problem. You suddenly run into problem, nobody there to bail you out. Then you have to spend in jail. Correct? Yes or no? So, it depends. So, now we have an alternative which is better than petrol. Now, you sitting on this, you think about the next alternative. But you cannot always aim for the best. You do that, you will never achieve that. Because you don't have a right path to reach there. You are now going from 0 to 1. That is, it happens for very rarely for somebody who becomes suddenly nobody yesterday, suddenly today become somebody. Right? But not everybody. The most probable approach is going this way. So, that is what everybody is doing, including researchers. So, you get this. But our being itself is this thing. But you cannot ask me, then I should not be there. No. Everything is there to enjoy. So, you should think that way. You should not think as if your being is there is damaging the world. World is entropy is increasing. Why should I increase the entropy of the world? Not required. This is the nature. See, energy is conserved. One day earth will be destroyed for sure. Whether you do something, not do something. You do something, it will destroy early. You don't do anything, it will destroy one more day. It will come later, but it will. Then supernova will form, this will form, that a new planet will form. Then it will take billion years for the life to evolve. This probably happened several times in the past, maybe happening several times after us. As we are nobody to do that. We are just here as like, we are directed by somebody, we just move in the chessboard, that's all. So enjoy in that the dynamics, over. Don't extrapolate too much saying that what is my presence, how it is matters. All that is nonsense. You do that, nothing can be done. So your presence is enjoying with the company of all the fellow citizens around you, that's all. Okay? Am I right? Nobody will answer this question, right? Why I should do this? Why I should live? Why you should? It's up to you anyway. But this is also a pleasure, right? This is also pleasure. Why you drink certain chocolate over the other chocolate drink? Well, you get pleasure there. Same like that. So ultimately, you want to be, happy or not, it's in your hand. Okay, don't go to that extrapolated thinking. Never do that. Just spend time. Spend and also remember that Tirukural, right? Which is the best wealth is your health. So you are not going to do anything. Many of the people you see who kind of dejected is they will have some problem in there, here or here, right? Correct? No, they are already infected. Infected people will always think, okay, just like that they will do because they have nothing to do. So you make sure health is perfect. Don't order Zomato, Swiggy in the midnight 12 o'clock. Eat at 3 o'clock and sleep at 5 o'clock. Get up at 11 o'clock. These kind of things you not do. Your body should have a pattern. That pattern you should continue. You should not disturb too much. Okay, once in a while you hang out is fine, but not regular activity. Every week, 4 or 5 days like that you are doing, what will happen? The body will lose strength. Then you will start feeling like that only. Because you are having already trouble inside. So, the best thing is to keep certain disciplines around you. With that, you try to interact with the people around you, enjoy life. Then you will see you don't want to leave the earth. Right? Those who don't do that will say all the time, no, I am going. Okay, go. What can we do? What can I tell? You tell me, you don't convince whatever I say. Nothing we can do. Right? No? So let's not get into that. Just enjoy the life. Okay? Thank you.